So as I mentioned here in discussion, like using a single measurement, so we place a ruler and we measure the height, the top of the first bar magnet and the bottom of the second bar magnet, and we just subtract. Like this distance is A, this distance is B. So B minus A will give us X. So, and we should mention, because look perpendicular, avoid parallax error, use set square, place the ruler close to the bar magnets. These are the things you should also mention. Student predicted that the relation between the f and the x was a form of f is equals to kxp, where k and p are the constant. How the graph of log f and log x should be determine the value of p. So if I take log both sides, so this will be equals to log f log k xp. In log, when two quantities are multiplied, we write them as addition, so it will be equals to log k plus log xp. And this will be equals to log f is equals to log k. Uh, when in a log, if it is log a raised to power b, so this will become as b log a. Okay. So if it is log x raised to power p, it will become p log x. And if I rearrange the equation, I will say log f is equals to p log x plus log k. We want to determine the value of a p, so we'll use the equation of a straight line y is equals to mx plus c. So on y-axis, if I plot a ln f log, not ln, log, log, log f, and on x-axis, if I plot log x, what will be my gradient? My gradient will be equals to p. So what we will mention, we'll mention, like, you don't have to show this whole solution in exam. You can write the direct answer, but you have to say, but to work out the answer, you have to rearrange the equation. So for it, this is the equation, what is important. So first you will write this equation, then you will say plot log f on y-axis and log x on x-axis. And the gradient of the graph will give us the value of p. So solution is not important. That solution which we did, like this is not important. But this is the final equation is important for a comparison. So this is comparison is having marks. This derivation is not having any marks. But still, to get this relation, you have to derive. The next student, the next is student varied the distance x and determined the corresponding f. He recorded the data, plot a graph for log f and log x on the grid opposite. Use additional column for your process data. So we want log x here and we want log f. Now, the important thing is, look, there are two ways to do such questions. One is, if you don't convert the unit, then the unit of the logs will also be same. Like, let's say the value of the x, the unit of x is millimeter. So what will the unit here? If you don't, if I use only 102, so I will take log 102. What is log 102? Log 102? So 2.01. So this I will write as 2.01. 2.0. So how to write the, like I took the whole as a log. So I substituted that as in a bracket. Okay. So this is not log, this is log x with a unit millimeter. And same thing, instead of converting a millimeter like into Newton, directly you can use So don't forget to put a bracket. If you write like this in exam, log x slash millimeter, they will consider as wrong. Okay. So it is 1.05. So we write 1.05. So same way you have to complete the grid. 2.07. Okay. Then 0.88. Okay. So same way you will complete, because I'm not plotting, I will not plot a graph. 2.11. I'll just explain an idea. Then plot a graph for log f and use additional. So determine the gradient. So this is a place where you will plot a graph. It should be a straight line, but it will not pass through origin. And then find the gradient of this straight line. Then student suggested that the relation between f and x is an inverse. Explain whether the graph support this suggestion. Look, after plotting the dots, do we know if we should draw a curve or yes, it should be a straight line. Why it should be a straight line? If you see, we derive this equation and we show that the gradient is p is a constant. So when we drive this equation, we wrote log f is equals to p log x plus log k. So p is when we compare y is equals to mx plus c, so gradient is constant. So constant, it must be a straight line. If it was not a constant, then it will not be a straight line. Straight line gradients are always constant. Then the student suggested that the relation between f and x is an inverse square. Explain whether your graph support this suggestion. So if the two, they have the inverse square means then like what does it means? The concept of an inverse square means they're inverse and vary with the square, means f is inversely proportional to x square. Or what will the equation? So f is equals to k over x square, or f is equals to k into x raised to power minus 2. Okay. Then if I plot a graph for log, so it will be log f will be equals to log k plus log x raised to power minus 2. When I rearrange the equation, so log f is equals to log k minus 2 log x. If I put x first, so it will be log f is equals to minus 2 log x plus log k. So if it was an inverse square relation and when I compare with the equation of straight line, y is equals to mx plus c. So what should be the gradient? The gradient should be, if there's an inverse square relation between the two quantity, then the gradient should be -2. Okay. So then how to know whether it is an inverse square? So you will compare your value with the gradient here. Like you will compare this value of a gradient with -2. Let's say this value was minus 1.9. So minus 1.9 is approximately equals to -2. So you will say, yes, it is inverse square. But if this value was something else, like -8 or -10 or -20, then you will say that they are not inverse square. There is no inverse square relation between the two quantities. The answer comes as minus 3.5. Okay. So the gradient is -3, but it should be 2. So minus 3.5 is not equal. Like here, this value of a minus 3.57 is not equal to -2. Because if they were having an inverse square relation, the gradient should be equals to -2. But the gradient is not equals to -2. It means that they don't have a inverse square relation. Is it clear? Which first part? This one, determine the gradient, or the last one? Okay, look, when two quantities are inverse square, they do not say inverse, they say f and x is inverse square relation. Means f is inversely proportional to x square. That is the inverse square relation. Whenever in mathematics we replace the proportionality sign, we replace with equal to and constant. So f is equals to k over x square, or f is equals to kx minus 2. Okay, because I move in numerator. Now if I take log both sides, so it will be log f is equals to log k plus log x raised to power minus 2. Log f is equals to log k constant, and the power will become the coefficient. So minus 2 log x. Or if I write the equation, I can say log f is equals to minus 2 log x plus log k. Then I compare with the equation of a straight line, y is equals to mx plus c. On y-axis, if I have log f, on x-axis, if I have log x, what should be my gradient? My gradient should be minus 2. When it is an inverse square, the gradient should be minus 2. But when we do this experiment, the gradient is minus 3.57. So it means minus 2 is not equal to minus 3.57. So they don't hold the inverse square relation. In question 4, a student made measurement for a circular convex lens. As you can see, front view and a side view, he measured a diameter and he measured the thickness. Student use a vernier caliper to measure a diameter. One technique. Look, when you use a vernier caliper or a micrometer, you should fix the object between the jaws of a vernier caliper or a micrometer and repeat the procedure with different orientation. Check for first thing, you should always check for zero error, because that is the most important thing. So check for zero error, which will, because when you check for zero error, it will reduce the systematic error. Like there will be no error because of system. And when you take the repeat with different orientation and taking a mean, so you reduce the random error. So mention that which error systematic, how do does one technique get 1 mark is for mentioning what technique. Like example, you will mention check for zero error, place between the jaws, check for zero error and then place the object between the jaws, and that will reduce the systematic error, that will score 2 marks. Or if you mention place the object between the jaws and measure from different orientation and take an average, which will reduce the random error, that will be the of also 2 mark. 1 mark is for technique, 1 mark is for which error will be reduced. A student estimated that the thickness was approximately 5 millimeter. Explain the most appropriate instrument that student should use for a single measurement. Your answer should include a calculation. So approximately 5 millimeter is there. That is the thickness of this. So usually what happen if you use a micrometer screw gauge, because if micrometer screw gauge is having the highest least count, like it can record a smallest value for 0.01 millimeter. That is for a micrometer screw gauge. Vernier caliper can measure 0.01 centimeter or zero point 0.1 millimeter. That is a vernier caliper. And a meter rule or a scale can measure 1 millimeter or a measuring tape. So if I want to measure 5 millimeter, I will prefer an instrument with a least, like which can record a very small value. So what about the percentage uncertainty? If I want to calculate the percentage uncertainty divided by value recorded into 100. What is the uncertainty of the instrument? Uncertainty of the instrument is a half of the least count. So this is the least count. These are the least counts. Least count means like smallest division on the scale. So what is the uncertainty? Uncertainty is half of the least count. Least count divided by 2. So if it is least count is 0.01, what will the uncertainty? It will be 0.005 divided by value recorded 5 into 100. So most appropriate instrument will say micrometer because it is having a lower uncertainty. And then we will show that its uncertainty will be the half of its resolution. What's the answer here? Because uncertainty is half of resolution. Why? When you have like two markings are there, let's say this is 0 and this is 0.01. Okay. But if the value is between 0 and 0.01, you can estimate, you can say this is about 0.005. Like you can use your estimation. That's why the uncertainty is the half of the least count. Clear? So it's the idea is that like estimation is there. So when you're using the uncertainty, always use the half of the least count. Okay. The next is U and V are measured by using a lens. Show that the uncertainty in F is about. So how to work out uncertainty? Look, first these two are the product. When two quantities are multiplied, we add the percentage uncertainty. Here, so what we'll do, we'll first work out the percent. We just need a uncertainty in F. First, we substitute the values to get the value of F, and then we'll work out the percentage uncertainty in U and the percentage uncertainty in, like the percentage uncertainty in U. What is the percentage uncertainty in U? Uncertainty divided by the value of a U recorded 29.6 into 100. Then uncertainty in V. This is uncertainty, percentage uncertainty in V. Uncertainty divided by, yes, you can take in fraction, but this is a percentage. So you represent in decimal. It's a percentage, that's why. 9.2 into 100. What's the answer for this one? Zero 0.33. Okay. So 0.33% in this. 0.52% in this. 521, 52%. Now, what is the uncertainty? The third, because we have U multiplied by V divided by U plus V. So first we find the percentage uncertainty in U and V. Then we need the percentage uncertainty in U plus V. So what is the percentage uncertainty in U plus V? So percentage uncertainty in U, because U plus V will count as one quantity. So percentage uncertainty in U plus V, what is a value for u plus v. And what about the uncertainty? Uncertainty always add. U is 0.1, V is also 0.1. So this will be 0.1 plus 0.1 divided by value of a U was 29.6 and V is 19.2 into 100. That will give us a percentage uncertainty in U plus UV. Point 0.4%. So 0.4%. So this is 0.4%, 0.52 and 0.33. Because we need the uncertainty in F, and how F is calculated. F is calculated U plus V, U into V. F is calculated U into V divided by U plus V. So uncertainty in U, which was 0.33, uncertainty in V, which is 0.52, and uncertainty in U plus V, which is 0.4. So we will add. So what's the answer? The percentage uncertainty? When you add them, why? Because uncertainty always add. Whenever you're finding the total uncertainty in F, you're finding a total uncertainty in F. So it will be a percentage uncertainty in V, percentage uncertainty in U and V, divide plus the percentage uncertainty. Yeah, even it's a division, multiplication, uncertainty always add. Like if I'm having a value X divided by Y, say Z is equals to, X divided by Y. So if I need the percentage uncertainty in Z, so it will be a percentage uncertainty in X plus the percentage uncertainty in Y. If I have X divided by Y plus B, so it will be a percentage uncertainty in X plus the percentage uncertainty in Y plus B. So uncertainty always add. Even quantities are multiplied, divided, added, subtracted. So this will give us the percentage uncertainty in F. And then after finding, like this is a focal length, so we'll work out 1.3%. Uncertainty always add, irrespective of the quantity which you are finding. This is one way of, so first, this is one way of finding the percentage uncertainty. So that will be the 0.15. So 0.15 is the uncertainty in F. There's also another way of doing the same question. You will try to figure it out, the maximum and the minimum value of F. Like you will find F minimum and you'll try to figure out F maximum. And the formula is maximum minus minimum divided by mean into 100. Sorry, maximum minus minimum divided by 2 will also give the uncertainty. What will the F minimum? F minimum is when U is small, V is small, and U plus V is greater. And what is the F maximum? F maximum is when U and V are the greater value and U plus V is a smaller value. That will be F max. And then F max minus F minimum divided by 2, that will also give us the uncertainty. That is another way of doing the same question. Okay? Is it clear? Determine a value of n. And then percentage, what is the value of n? You just have to substitute that value. Like you just have to substitute the value of a D is there, T is there, F is there. The next is percentage uncertainty in F, n. Now, how to work out the percentage uncertainty in n? And the expression for n is given. Uh, like what is n here? N is equals to 1 plus d square divided by 8tf. Okay, that is n is given. So we will work out the same way it can be done. Like you can work out the maximum value of n, then you will work out the minimum value of n, and then maximum minus minimum divided by 2 will give uncertainty, and the value of the n. Like there are two ways to do this question. First, I will find n minimum, then I will find n maximum, and then the uncertainty will be maximum minus minimum divided by 2. That will be the uncertainty, and percentage uncertainty will be an uncertainty divided by value recorded of n into 1, or a mean value into 100. That will give us a percentage uncertainty. This is one way of doing it. Okay. What is the second way of doing the same question? Because how n is calculated, it is d square. So means it will be a percentage uncertainty in d multiplied by 2, because what is the power is written, that will be multiplied by that, the percentage uncertainty will be multiplied by that number. Then what is a percentage uncertainty in t? Why we did not include 1? Because 1 is a constant. 1 does not have uncertainty. Why we did not include 8? 8 is also a constant. So it will be 0.01 divided by, like this will be a percentage uncertainty in t, and then we'll have a percentage uncertainty in f. So this will be 0.02 divided by 5.02 into 100 and then multiply by 2. Why it is multiplied by 2? Because the power 2 is there. And this will be 0.01 divided by 4.28 into 100. And this is 0.2 divided by 11.6 into 100. And after getting the percentages, what we'll do? We'll just simply add the percentage uncertainty into d into 2 plus percentage uncertainty in t plus the percentage uncertainty in f. Is it clear? The next is refractive index is 1.52. Determine the percentage answer. Determine the percentage answer. We did deduce whether a lens could be made up of a crown glass. Refractive index of a crown glass is this. And so what we do, we get the value of n. Let's, like we can take any value. It will be exact number. This value is 1.63. Okay. This is 1.63. So what we will do, if you want to compare, we compare two things. We compare percentage difference with percentage uncertainty. That is always a comparison. Okay. If we found that the percentage difference, when we calculate the percentage difference, which is maximum minus minimum divided by standard into 100, that is the percentage difference. And we compare with the percentage uncertainty. If the percentage difference is higher, then the percentage uncertainty will say the values are not equal. But if the percentage uncertainty is greater, then the percentage difference will say the values are equal. Like how to calculate a percentage difference? We got the value 1.6. Percentage difference is the maximum minus minimum divided by, because we know the standard value. So in this case, we'll divide by the standard value. So standard is 1.52 into 100. What is the answer? But because yes, you can compare the two, but it's not about in exam, it's always a comparison between a percentage difference and a percentage uncertainty. So maximum minus minimum, this is 1.63 or 1 minus 1.52 divided by 1.52 into 100. It's about 7%, 7.2%. And then percentage uncertainty, which we calculated in the previous example, we'll compare that. Let's say any number, let's say it is 2%. So if the percentage difference is higher than the percentage uncertainty, you will say no, it is not made up of a same material. But if a percentage difference is less than the percentage uncertainty, you will say it is made up of same. So as the percentage difference is greater than the percentage uncertainty, the lens is not made up of a crown glass. So in exam, it's always a comparison, always compare, okay? So always, whenever comparing the results, compare the percentage difference and percentage uncertainty.